So thank you everyone. I am Andrea Ferrone from Myant, and today I want to introduce integration and connection, the challenge of textile computing in 2021. So before go ahead, I would like to start with a question, and the question is, how do we define an electronic textile? A definition that I love is, what makes smart fabric revolutionary is that they have the ability to do many things that traditional fabric cannot, including communicate, transform, conduct energy, and even grow. I think this definition is wonderful. It actually is the reality, but I'm not sure if with just this definition we can well describe what is an electronic textile or a computing textile. Because otherwise, this is what we are going to have. We are going to have a system that is not well integrated. We are going to have a system that is not designed for scalability and for production. So please, thinking about what will be your definition. In the meanwhile, I will introduce what is Myant and what we are doing. So Myant is working on a new definition of society, and it's called Society 5.0. So our society starts from 1.0, where hunting and gathering were the principal action, then moving to agriculture and industrial. Now we are information society, where a lot of information are exchanged by media. What Myant wants to do is support, promote, and facilitate and create the tools for the concept of Society 5.0, where there is a high degree of cyber communication and transmission of information. That means that through artificial intelligence and big data, different information, including personal real-time physiological data, healthcare information, treatments, information, and environmental information can be shared, that can be computed. And this can enable comfortable living using robots to provide living support and conversation partner, promote health living, early detection of illness through real-time automatic health checkup, provide optimal treatments anywhere through the sharing of physiological and medical data, using robots to ease on the side burden of healthcare and caregiving. This solution will help to reduce the social costs associated with healthcare and caregiving and solve labor shortage problem at the healthcare side. So what is the current situation of wearable? So we have a single point solution. We have stickers and patches that have a limitation. We have injectables that are still invasive. We have wearables, but I mean, they don't talk each other, and the majority we love have wearables on our wrist with our smartwatches. And there is limitation in data accuracy, and power restriction and continuous monitor is always a challenge. So what we propose as Myant is a textile computing. So basically we have our clothing, our textile everywhere, at home, at work, where we play, where we do sport. And having this computing with us all the days will introduce a continuous monitors. And we have a facility for that. So we build the entire facility around this concept, modified machine following ISO standard 901 and ISO standard for medical device 13485. So that gave us the opportunity to integrate better and have different processes in place and control all of them. And this gave us a huge advantage. Of course, as for us, is a huge risk, like have this kind of approach. So just for moving forward, basically our competence starts from R&D to production, having a sampling and rapid prototypes. And our capabilities is similar what you can find in the state of art. So we have EEG, ECG, medication, pressure, chemical, temperature, and so on, as well as capability as give input and has a heat, haptic feedback, electrical stimulation. So our team is huge, and we found that we need expertise in textile and engineering. And we have a large and diverse range of expertise. But then, as you can see, this is a whole slides from another presentation. And as you can see, even these slides, there is a fracture between textile and engineering. And this because this fracture is in our mind is real, because what is missing is integration. So integration is a key part if we want to move forward to have those technology really succeed in the market. And for that reason, now in 2021, we are really focused on integration. We are really focused on have this process scalable and manufacturable. So what are the challenges? The integration challenges, of course, are in machine and process, are in material and components, and in standard regulation that sometimes there are no standards. So there is a need to develop and create each of them. But where we start from textile, we start from electronics. Of course, from electronics, we have a huge range of machine and automatic process, as well with the style. And how we mitigate the risk to go ahead and develop a machine for these e-textile, for these computing textile. One of approach, of course, is the industry approach. So is take the less expensive action that creates an outcome. And so far, what has been recognized is going on material and components. And this is a reality that it is today, nowadays is real. We are working on material. Also, researchers are working on material and components to have these very cheap wires or membranes that can be implemented. But let's see what is the state of art. So Myant, for example, is working on flat knitting and circular knitting to have this very advanced conducting wires, very advanced conducting thread. Then there is weaving, there is sewing and embroidery, and then there is printing and lamination. From my point of view, the difficulties of integration goes from left to right. So the left one, knitting, is the most difficult one. Because there is a lot of friction, there is a lot of parts that are losing during the process. And going to the right, printing and lamination, that process is well established, and having the fusion with textile is not a big challenge. The process is smoothly changeable. So Myant focus on the two of them. And I believe that with knitting, we have such much more capabilities of structuring in 3D, having complex structure, which we cannot have in weaving, sewing, and embroidery. So about material, we already introduced in this conference some of the material. We have metal wire, twisted metal wire, metal fibers, and conducting coating. These are some examples available also in the market. So twisted metal wire, metal fibers, and you can see the details. As you can see, they are not perfect. They are not perfect in the sense that if you're thinking about if we insert those wires in a knitting machine, for sure, we are going to have some difficulty knitting. We cannot produce at the same speed that we are producing a normal clothes or a normal fabric. So we have to modify the machine. We have to change the process as well. And also those materials have limitation because, for example, conducting coating, he has an amazing resistance, very low, but sometimes it's not reliable for washing cycle, and sometimes he has some other chemical compatibility issues. So as I already mentioned, some of the issues are friction, durability, reliability, reproducibility, and these for process compatibility with the machines, with washing cycle, connection failure, and resistance as well. So what we are focusing on Myant is embedding conducting yarn and wires into knitting structure. We also then have a collaboration for have micro wires, and we call micro wires because it's a combination of those fiber in a way that we will have to minimum modify the knitting machine to have amazing instruction similar to the normal clothing. And then we are able to knit in like carbon plating yarn with the percentage of conductivity that we need based on the application. Now, if we're thinking about the machine and process, these are some examples of machine that are using in textile and in electronics. And some, of course, are used at Myant as well. And we modify them. We modify them because there are no machines like exactly designed for what we are doing. And this is a need that needs to be addressed. So just for example, this is a hot bar soldering. This is a laser ablation process that we use on 2 of our fabrics. And of course, it's not easy to see, but there are several wires interconnecting here. Also here is a hub of 4 connections all together. And this is the result with the hot bar soldering. They are melt together, which is they will be connected well, smoothly. And with the laser ablation, you can see how the exceeding material was removed, and these chains are well connected all together. So what should we expect next? So we have some products in our chain. We have some reality that are going to be in the market soon. And those we establish, basically we construct everything, because as I said, there is a need that company and industries will start to develop those machines to enable other companies to produce this smart textile. So we build the system. We build also the software and all the missing parts that are needed in order for have this smart garment and a reality on the shelf. So thank you very much for your attention. And these are my contacts. If you have any question, please reach out.